Next, we will summarize the definitions of limits and develop the graphing approach to find the limits of functions. The idea behind the approach is very simple. Let's say we have to find the limit of some function as x approaches to some target value. First thing we do is use a graphing device to graph this function. Then, depending on the target value, we will try to identify one of the familiar patterns and describe it using the language of limits. If x approaches to some value a from the left, then we will try to identify these three behaviors. If x approaches to some value a from the right, then we will try to identify these three behaviors. If x approaches to some value a from both sides, then we will try to identify these three behaviors. And if x approaches to negative infinity, then we'll try to identify these three behaviors. And finally, if x approaches to positive infinity, then we'll try to identify these three behaviors. And if a function doesn't have any of the recognizable behaviors, then we'll say the limit doesn't exist, as in these three examples. We summarized all of the 15 graphing definitions of limits and introduced the graphing approach that allows us to find a limit of any function when a graph of a function is provided or a graphing device is available.